So now we're in chapter 2.7, and we're going to just put all of the information that we learned yesterday into actually sketching these graphs if we didn't have a graphing calculator. So before we get into it, remember for any function, we're going to be doing this all throughout the year. For any function, if you want to find an x-intercept, that means that you're setting the function, whatever it is, equal to 0 and solving. And then if you're supposed to find the y-intercept for any function, that means evaluate f of 0. Plug 0 in for x, see what you get. Okay, so when we're graphing these things, I just want to do a few examples, and instead of writing out all the rules, let's just do these examples, and you'll be asked to find this various information. We'll go from there. So first thing is, can you simplify f of x? In this case, the answer is no, it doesn't factor, nothing reduces. So we can get right down to finding some of our information. The vertical asymptote is when we set x minus 2 equal to 0, and we get x equals 2. Make sure you're writing equations. You're not just writing the number 2. I won't give you credit for that, and neither will the AP test. There are no holes in the graph because there was no simplification, so I'm just going to write no solution for that. For the horizontal asymptote equation, this is bottom heavy, right? There is no x in the numerator or an x to the 0 if you want to write one in, over an x to the first. So the rule for bottom heavy is y equals 0. And there's no slant asymptote. If there is a horizontal asymptote, there can't be a slant. But remember, slant is only if it's top heavy by 1 degree. Okay, and then the y-intercept is finding f of 0. That's 3 over 0 minus 2. So 0 for x, negative 3 over 2 for y. There's our y-intercept. I would like you to write it as an ordered pair so that you plot it in the correct location. And then x-intercepts, we did this way back in the beginning of the year with chapter 1. X-intercepts come by setting f of x equal to 0. Well, if we set 3 over x minus 2 equal to 0, remember, if there's no variable up here, a fraction can't equal 0, or we just got done with rational equations. If you multiply x minus 2, because it's an equation, you're allowed to multiply that to the other side, but you get 3 equals 0, which is not true. So there are no x-intercepts, and that's actually really common for rational equations, especially if the horizontal asymptote is 0. Just because the horizontal asymptote is 0, by the way, doesn't mean that we'll never have x-intercepts. It's true that some graphs cross through their horizontal and slant asymptotes at zeros, and then in the long run, those just describe the end behavior of the rational. Vertical asymptotes you'll never have a point on because those are undefined values, but horizontal and slant, that's just helping with end behavior. It's not talking about places where the graph is not defined. All right, so now we have to graph this thing. I always start with the asymptotes, do a vertical dotted line, dotted just to give you the guardrails but show it's not part of the final graph, and a horizontal dotted line through y equals 0. And then if I got any points out of the x and y-intercept, I plot those. So negative 1.5 on the y-intercept. And these rational graphs, we've done a couple in our graphing calculators. And remember the parent function, 1 over x, it has these curved branches. So if you want to plot extra points in this corner, you can. But we know there are no other x-intercepts. And if we wanted to plug in 1, we could. If we plug in 1, we get 3 over 1 minus 2, we get negative 3. So if you want one more point, you can. But I'm okay with you guys just sketching that you should have a curved branch that kind of fits into this little corner made by the two asymptotes. And that's good enough. So 1 point on each branch is good enough for me if it's just a little 4-quadrant rational graph like this. We do need to plug in something on the right side, although we should know that the other branch is up here based on just the fact that it's 3 over x minus 2. It can be positive on that side. But just plug in a number to be sure. So if you plug in 3, you get 3 over 1, so 3, 3. Just be careful when you're plotting the extra points. It's easy to accidentally treat where the asymptotes cross as the origin. But remember, the origin's over here. I went 3, 3. Okay, so that's it for that one. A more complicated rational function is this one. It's more complicated because if you factor that denominator, there are 2 vertical asymptotes. Neither one of those factors cancel out with anything. So for vertical asymptote equations, we have x equals 2 and x equals -1. And the reason that makes things more complicated, no holes, is because it divides the graph into 3 sections instead of just 2, one on the left, one on the right. What about the horizontal asymptote equation? Whether you factored this or not, it's still an x over an x squared. So it's bottom heavy again. That means that y equals 0, once again, is the horizontal asymptote, and that means we don't have a slant. So let's put in the asymptotes first. -1. Try to get that little box off of here. There we go. So -1, and then the other one was at +2, and y equals 0. So you get this sort of like h. So we're going to have a branch on the far left, either up here or down here. And we're going to have a branch in the middle, which we'll figure out. We're going to have a branch somewhere on the right. So 3 branches to this. What about the y-intercept? If we plug in 0, what do we get? We get 0 over -2. It's important to check that you get 0 over a non-zero number because that is equal to 0. 0 divided by 0 means you could have simplified something. That's called an indeterminate form, and you'll see more about that in calculus. Okay, so the y-intercept is 0, 0. Well, if the y-intercept is 0, 0, so is the x-intercept. But also you could say f of x equals 0 if x over x squared minus x minus 2 equals 0. You're always going to multiply the denominator over to the other side. So it's really just setting the numerator equal to 0 for these problems to figure out the x-intercept. Okay, I only have 1 point on the graph so far. And the hardest section, or the section that takes the most work, is this middle section here because I have 0, 0, but I don't have whether the graph goes up to the left or down or right or what. So we need to figure out, we need to plug in some extra points. I didn't leave you much room here. So I'm going to do extra points up here. We need to figure out what's -1/2 or some fraction. I like to choose the halves. What's f of -1/2? And I just need the sign on this. So I don't really need to do all of the fraction work. I just need to say -1/2 goes in for the x on the top. I like to put into the factored version because it's easier to see what's negative and what's positive. So if you just, without really doing any math, if you just plug in -1/2 in for these 3 x's, so that's a negative in the numerator. And then the first parentheses is -2.5. Second one is +1/2. A negative divided by this negative will be positive overall. So all I really care about is that this graph goes up to the left. We know because of vertical asymptotes, it's got to increase to infinity or decrease to -infinity. We just didn't know which way. And so if we plug a number in and we get a positive or a negative, we know the rest of the graph has to have that same behavior. We also should plug in f of 1. If I plug in 1, I get 1 over 1 minus 2 over 1 plus 1. It's -1/2. So I can plot 1, -1/2. And do something like this. So the only time I don't really bother with the actual height, like that one I did plot, -1/2, it's just when it's a fraction. I just, if ultimately, does it matter where I plot this point if I know that whole space is going up? Not really, but here I kind of like to see that there's this bend. We also need to figure out where the other 2 branches are, so don't forget that you should also find f of, if we go to the left, f of -2, for example, and to the right of that vertical asymptote, maybe f of 3. You need the actual heights for these so that you can more accurately sketch the branch in. So -2 over -4 times -1. -2 over +4 is -1/2. So -2, -1/2. Sketch that branch in. That was that was kind of sloppy. You want these to look like, you don't want to do this. I see a lot of this every year, just kind of sloppily doing this, but that is wrong. And I would count off for that. You don't need to give me long arrows or anything, but you need to show that the graph is approaching the horizontal asymptote. It can't be going away from it. All right, and then f of 3. 3 over 3 minus 2 is 1. 3 plus 1 is 4. 3/4. So 1, 2, 3, 3/4. Again, sketch these branches in as nicely as you can. So that's a more complicated graph. Just 2 more examples. So our next graph, can we simplify this at all? It looks like we have some factoring to do. If I take out a 2, I get x squared minus 9. And x squared minus 4 is a difference of squares. And x squared minus 9 is a difference of squares. Oh my. Now this looks like it's going to be a lot because nothing canceled. But let's just kind of see what happens. So vertical asymptote equations, x equals plus or minus 2. I just realized I haven't given you any holes. Sorry, we will definitely have holes to practice in the homework. Anyway, x equals plus or minus 2. Maybe I'll sketch these in as I go. Holes, none, because nothing canceled. Horizontal asymptote equations, this one's a tie. And remember the rules that you divide by the leading coefficients. 2x squared over 1x squared is 2 over 1, or just y equals 2. So finally we get something other than 0. Again, we have this kind of H shape going on. There's no slant asymptote because this is not top heavy by 1 degree. Okay, for the y-intercept, when we plug in 0, we get, now plugging in 0 is easier to do in the original. You get -18 over -4, which is really +9 over 2, which is really 4.5. With graphing, it does make sense to think about mixed numbers so that you can accurately place that fraction. 1, 2, 3, 4.5. Okay, now here's a cool thing. I do not need to graph any extra points for this middle section, and I'll show you why. But before I get into that, I'm getting ahead of myself. Let's find x-intercepts first. X-intercepts are when you set the function equal to 0. For a rational function, because you're always going to multiply the denominator to both sides, and that'll make it 0 over here, you're really just saying 1 is 2x squared minus 18 equal to 0. And that's at plus or minus 3. We already showed that with the factoring. 2, 3. Okay, so here's the great thing about this problem. This looked like it was going to be terrible at first, but we have 1 point in each section between, to the left of the vertical asymptote, between, and to the right. We know that the corner pieces have to fit into the corner. So without really needing any extra points, you can sketch those in, although you're welcome to do more points if you're not sure. And I know that the top piece has to open up. Why do I know that? It's because of the x-intercepts. We found that there were exactly 2 x-intercepts for this function, right? If this were to open down, I would be creating 2 more x-intercepts. And a graph isn't just going to go down and then like stop. It can't just do one of those. Also, even though a function is allowed to cross through a horizontal asymptote, I believe that really only happens if the horizontal asymptote is at 0 and it's the zeros that are crossing through. So you can save yourself a bit of time by just sketching this in. It's going to be something curved that goes to either side. It might not quite look like a parabola, but this is as accurate as I would require you to be. Okay, final graph. I can factor a little bit, but that doesn't help me cancel anything. So the vertical asymptote is x equals -1. No holes. Again, sorry, I'll make sure that we practice that in the homework and go over it. Horizontal asymptote equation. This one's top heavy finally, so there's no horizontal asymptote, which means we have to do the slant asymptote work. So we're putting x plus 1 on the outside, dividing x squared minus x, put a plus 0 constant on there just in case. We multiply x by x to get x squared, then distribute. Careful when you subtract here. Negative x minus x is negative 2x. We multiply x by negative 2 to get negative 2x. There is a remainder of 2. But remember, the equation overall, because we're looking at values at infinity or negative infinity, yeah, x minus 2 will be some sort of value, but plus 2 divided by 1 billion, that's really like adding 0. So it's just y equals x minus 2. You always ignore the remainder. And then let's find the x and y intercepts before we plot those asymptotes. So the y-intercept, if I do f of 0, I got 0 over 1. So 0, 0 is an x-intercept, or is a y-intercept, and it's also the x-intercept. Okay, let's put in the vertical asymptote at -1. And remember, we did linear equations in the beginning of the year. This has a y-intercept of -2 and a slope of 1. I suggest using your dashes to be the slope. It does need to be, like when we did lines, we just graphed 2 points and sketched the line. But these are the guardrails for our function, so we want to make this a bit more accurate. And then the way that these functions work, if you have slant asymptotes like this, either the function fits in these corners or it fits in the wide parts. So the fact that I have this little curve here and no other x-intercept means I know that this kind of bounces off of this and heads out this way. If you're unsure, you could plug in 1 or 2 or whatever. And then for the bottom piece, I know the other piece is in this branch. I could probably use symmetry, but that's always hard for my eye to see. So I'm just going to say, what do I get when I plug in -2? When I plug in -2, I get -2 times -3 over -2 plus 1. +6 over -1. I get -2, -6 there. And again, our graph should be going toward the slant asymptote and toward the vertical asymptote. You don't want to get lazy and sketch it like that. You don't want to curve it down. Okay, that's it for today. We're going to have lots of practice with graphing for homework, and we can come back tomorrow if we had any questions about the holes or anything else.